what is QA, QC, QV differences we have been discussed, and we have been discussed about the different type of environments. What are the different environments we do have it, and we wanted to take it up on these particular three aspects. What we need to discuss on this. And anyways, as I said, so for API, that will be a long-term course, which it will take a minimum of 9 to 10 hours of training. So what is an API and how the APIs are there, how the APIs are tested, and how the things are there. So that we have been given the tutorial for this. So hope you guys will go on this. So now the three pending items which we wanted to complete this, and then we wanted to go for the other topics. Okay, so now here the first topic which the pending items is the RAD, and as I told you, spiral we will not discuss. So because this is a risk analytic model, so this is not popular, and then this is little bit confusing. So that's the reason I don't want to trouble you to get into this. Now we will be discussing about RAD, and then we'll be discussing about V, and then already we guys has been completed with the Agile. So did we miss anything apart from this? Okay, so let's first started with these two models, and then we'll come to these two things. Let's see how many things we can complete on this one. Okay, so coming back, so what is our what we are planning to do on this particular aspect? So just let me pull out this whiteboard. Okay, so let me start on it. So the RAD model. So now, as you guys know that, so already we have been discussed as part of Sdlc, and as part of the Sdlc, we do have the different phases, which we do have the requirement gathering, which are analysis, design, implementation, coding, testing, and deployment, and then maintenance. Now these are the different phases we have it, and after this one, the Sdlc consists of different type of Sdlc models, different type of Sdlc models. Okay, now what are the different type of Sdlc models which we have been look after? So we have been seeing, first one is waterfall model,
incremental model, prototype model,
and agile,
so
RAD model,
rad model.
now, okay, so actually agile should be the last. So as he taken up, so now what means, we have been seeing the waterfall, incremental, prototype, and here we wanted to see another two models, which is the
RAD,
RAD
V model.
and V model.
V model.
So once after all these things, then only the agile comes into the picture. If you've seen in the agile, so these are the advantage, whatever the advantage be, every model will have pros and cons, right? Now, all the advantages of this particular models has been taken and then integrated into this particular agile model. So that's where this was very popular. I think you'll be talking about the 12 principles of the agile, and then how it has been derived. So all those information, hope you guys have been knowing about it, right?
Yes.
Cool.
Yes,
so now
sir.
coming back to a RAD model. So now here, this is what we wanted to get started with it, right? Now RAD. RAD means rapid application development. The name itself, it was saying that rapid. What do you meant by rapid? So now, for an example, now in the COVID, we will be talking about, hey, rapid test.
Fast.
What is that? Rapid means
Fast.
Very quickly, fast.
fast. Now we wanted to make it very quick. Okay. So now when we wanted to do this particular RAD model, now what? Just give me 1 second. Okay, so now very means rapid application development. Now how this particular RAD model will work? So for an example, I wanted to develop certain models. Like for an example, I wanted to, same old Gmail, we can take that. In the Gmail, we do have a lot of other modules out there. Now for an example, the modules like, what else the modules we have? Inbox, and we do have outbox, and we do have trash, and we do have spam. Now, usually how the development team will be doing, there will be a sequential development of these particular modules. Now, first I need to develop the inbox. Second, I need to develop the outbox. Third, I need to develop the trash. So now for an example, if it is taking 10 days, This is taking 5 days, and then it is taking another 15 days, another it is taking the 10 days. I'm just randomly giving some number. Now overall, how many days I need to spend? 10, 15, 30, 40 days I need to spend on this. To complete this all, I wanted to spend the 40 days. Now how many resources it will be there? So probably I'll be having 8 resources. I'm just giving some random number. Okay, 8 resources take 10 days to complete the inbox. 5 resources take 8 resources take 5 days to complete the outbox, same trash and spam. So this is how it was happening, right? This is how we do it. Now consider that, okay, consider that without having sorry, I got distracted. Consider that now this is 40 days and we do have 8 resources which you can do. Now if I increase this particular resources to 24, so now how we can, what we wanted to do is we will be creating a team 1, team 2, team 3. Now here I have 8 resource, 8 resource, 8 resource. Now what I'll try to do, I'll take the inbox, I'll take spam, and I'll take outbox. You see, within 10 days, 10 days, and 15 days, we can complete this. So now when I completed this one, immediate another 5 days, means that this team is ideal or this team is ideal. I can take that particular module and I can complete it. Means overall within 15 days, I can complete all my things, right? See how many days I have saved? 25 days I have been saved. So now what it happened is there would be each different team. Now what this particular team will do is, they will be developing the inbox. These guys will be developing the spam. These guys are developing the outbox, and remaining whatever the modules which have the time. So now this is outbox, right? They will take this outbox. Consider this is the trash, right? So trash 15 days. They will take complete this one, and I have another module like compose mail, which I take 5 days. Now here also it goes for 45. Consider that here also trash. So now with whatever the work which I can complete within 45 days, within 15 days I can complete with these 3 teams. Now what this particular team will do, hey, same once again this particular thing: requirement gathering, analysis, designing, coding, testing, deployment, and maintenance. So this team follows the same, this team follows the same, this team follows the same. What it will happen at the end of the day is they will merge all these things at one shot. So this is called Big Bang approach. Where we have been seeing this particular Big Bang approach?
In integration testing.
In integration testing, where?
What?
Integration testing is means integration testing consists of approaches. Integration approaches. In the integration approaches, the third one is the Big Bang approach. So now you understood, right? So now this is the dot which you need to connect it. So now how this particular Big Bang approach will be done is, so they complete all these particular modules and merge all these particular, integrate all these particular modules at one shot. When they started to, did you remember our levels of testing? What is the levels of it? Okay.
Unit level.
Unit level, module integration.
I'll come. So can you, Aisha, can you tell me what is this levels of testing? Can you tell me the different levels?
Unit testing, unit level, module level, integration level, system level, UAT level.
So now unit level, always remember, not unit testing, unit level, module level, integration level, system level, UAT level. Now, when you see that this integration level, see here they have done all the functional testing and all. You remember, right? Unit and then functional means the development people has been done the unit level, and the module level functional testing and all the things are covered by the our QA team, and everything will be done while doing the integration testing. So now if you see here, this is where the integration has been done. You need to understand in the Sdlc models how this particular pyramid will be working for us. So that is the connection which I wanted to give now. Now, if you see here, this is how Now we have been integrated, means first we have done the unit level. The developer means here you seen it, right? The developer developed the code and then he completes the unit testing, and the testing, the complete functional testing. Always you remember, functional testing would be tested first, because all the functionality has been tested. Now once after testing this particular function, now I need to go for the integration testing. So now during the integration testing, the RAD model, they integrate all the modules at one shot and then they will test it. Now here, this is what a big blast it was coming up. So now, because if I integrated module 1 to module 2 and then module 3, module 4, so then this would be a perfect choice, or not a perfect choice, but the issues might be less. If I got an issue, I can know that, hey, when I integrated with this, I'm getting the issue. When I'm integrating with this, I'm getting the issue. If I integrated all this at one shot, where from which module is this error is coming? How can I know it? So this became a bigger challenge for the team. Means it consumed. See now where the work need to be completed in 15 days, it was taking more than that time. So now they need to debug and analysis. Hey, because we need to know the RCA. What is RCA?
Root cause analysis.
Root cause analysis. What do you mean by root cause analysis? Is, hey, what is the main reason for causing this particular bug or causing this particular issue? What is the basic root cause? You need to tell me that particular basic reason, so that always you remember, there is a tree, okay, for this particular tree. Now they have different branches, and this particular branch is spoiled. Now if you remove this particular branch, and another branch will be impacted. Another means if you remove this branch, another branch is impacted. You will be removing this. Rather than doing a branch by branch, you need to cut down so that it will grow a new tree, right? So the same thing. So always you should remember what would be the root cause of the problem and fix the root cause of the problem, not the superficial layer. So that's the reason whenever we have raised a bug, we will be analyzing this particular root cause analysis. For doing this particular root cause analysis, there are different techniques in the market. Like in Six Sigma, we do have 5 whys or fishbone analysis like this. I'll try to show you something for one of the project which we have been done. Just give me 1 second. I just see, this is one of the root cause analysis which we wanted to do it out. So now if you see here, now this is for only for your educational purpose. I'm opening and showing it. So this is confidential information, but still how we have done in the real time. So just if I shown you, it would be much more useful for you. That's the reason I was just trying to show it. Now here you're seeing it, right? The bugs in the production means in the production, I have a lot of bugs. Because of this one, what it will happen? The team will lose the confidence on the testing. So now this is what the problem statement. Now, what are the root causes for this? So if you see here, this is like a fish bone. Like when we remove the fish flush, you will be seeing it, right? Like a middle vertebra. And then we'll be having multiple vertebrae, right? The same way, so here we can have that particular thing. And these are the reasons. Hey, we are not doing the basic validation. We are not making the test coverage and metrics. We are not properly writing the test cases designed well and maintained. And we don't have the guidelines in the documentation. We don't have the testing practices and the governances. And we don't have the automation approaches in the levels. So now these are all the reasons which it was creating, or which it was deriving the problem or cascading the problem to the bugs in the production. So this is how the bugs in the production will be created. So now this is what the root cause analysis. So now fishbone technique is one of the famous from the Six Sigma. Now we do have another techniques like 5 whys and other things are there. So this is how these things would be derived. Okay, coming back here. Now these things would be derived. So that is how we will be doing that particular. See now doing this particular RCA taken a lot of time, because if it is integrated with 1 and 2 modules, I can easily identify which module have this problem. But consider that if I have 10 modules I have been integrated, I need to revisit each and every module, right? Where it consumes a lot of time. So because it consumes a lot of time, once again, it was taking more amount of time. So when you take in more amount of time, I'm investing more amount of resources. When resources are increased, cost increased, right? And the time is also increased. Now, these are all the disadvantages of the RAD model. That's the reason this we tried it and then it was failed in the market. Got it? Any questions in the RAD? Any questions? Any other questions? Okay, so if there is no questions, then we'll go for the next one. Now, so see, now still the problems are not yet solved. So now when I go for the SDLC model, so still my problems are not solved for me. So it was still taking the time and still it was happening. Now we tried out with the different SDLC models. We have been tried with uh, waterfall. We tried with incremental prototype RAD. And the next model, which we have been tried for V model. See, now what usually we wanted, the basic intention, time to market is the most important. Time to market means as quickly as possible, I reach to the market. This is what the most important. I think on this one, you'll be having a lot of discussion in your agile classes, right? Yes, no?
Yes.
So time to market is one of the most important factor. Example, I given you an example of AHA, right? So if at all he don't released in the pandemic, will be like this. Or now once after all the theaters and everything opened, so now if I released any OTT platform, will it be popular? See, always we should remember that demand and supply. When there is a demand, at that time, if you supply, you would be clicked into the market. And you have an excellent idea. Actually, we do have a lot of thoughts. Before 15 years, 20 years, I met with an accident and I was into my hospital, and we used to think like sitting idle, and I don't like to read the books. One of my friend sat with me, and then they'll be reading that particular books, and then that horror novels. So I used to hear out that particular novels. So then we thought like, hey, see, I'm lazy and I don't want to hear all this. So the same thing, many of the people would be like me. So why can't we record all these things and then keep it? So this we thought through in 2006-7 that time. Nowadays we do have a very popular book, means things are there, Audible from Google, and we do have short stories. So now that would be a biggest a revolutionary idea in the market. See, what I'm trying to tell you is when we have an idea, hitting to the market as quickly as possible, that is what the business. That is where you will grab the business. If you're delayed in the market, your ideas and these things will be less. So that's the reason any particular SDLC model. So the first thing you need to remember that which it will help you to go time to market, means which it will go to the market as quickly as possible with the less number of resources. Less number means here the time is less, resources is less, cost is less. Then you will be getting that the better ROI. What is ROI?
Return of investment.
Return on investment. See, remember that return on investment means anyone do the business only on one factor. See, I invested X amount, I should get X plus. this percentage, Y amount is what I wanted. This is what the business, right? As quickly as possible, if he is trying to see that amount so that he can reinvest into another businesses. So that's a business strategies which we will follow. So now for creating the product itself, it taken 1 year of time. And when you go to the market, by that time, that idea is old and you are not able to sustain in the business. Will the business will sustain?
No.
So keeping these all things in the mind, the next models, it was evolved in this particular pattern, which is like a V model. So now if you go to this particular V model, you can clearly understand that, hey, what is this particular V model? Now, if you see here, why it was called V model means it is in the V shape. And here you can see that V here, two V's are there. One is verification and one is validation. These are the verification phases and these are the validation phases. And the most important interview question, if means all these, I don't know nowadays the people are asking or not, because none of the people are going for the manual testing. So because everyone was going on the automation part, so that's the reason the questions are very less on this particular aspects. But the people should know, many of the people don't even understand what do you meant by verification, what do you meant by validation. So the most important factor in understanding the V model, we should know the basic terms like what do you mean by, and even now the topic which we have it, right? Verification.
Yes.
See, as soon as I clicked verification versus, it came as validation. So now this is very easy to understand. So that's the reason I just take for this. We do have very good things like a Greek of Greeks and this C. Now, and one more small tip for you, whenever you search for something, so now the first links you need to refer, because Google can crawl to the content and understand what the content and whether they have been given appropriate content, appropriate image, supporting links, articles, everything they'll be doing it. So this is called SEO, search engine optimization. That's the reason if you're given a good content, by default, Google will populate your link at first. And if you pay money also, they will not do this. So that's the reason the people are investing, the companies are investing some huge amount on this particular search engine optimization. So there are certain rules and regulation. If you search for anything, not only the verification and validation, if you wanted to search for a movie or you are searching for anything, so which link is coming first means the link will have a lot of images with a respective content, with a respective of these things. So that's where these particular informations will be taken and then they will be keeping according to it. Okay, so now because I means already means always we will be referring this one, so that's the reason we just came to this particular document. Now here, did you guys gone through the static testing and dynamic testing?
Yes, sir.
What is static testing and dynamic testing?
Static testing is comes under the verification, and the dynamic testing comes under the validation.
You shouldn't tell, see, now whenever asking the verification and validation, will you say that verification is a static testing and validation is a dynamic testing? So you we should able to understand what exactly the process of the things. Yeah, someone is saying.
Static testing is nothing but related to the documents, the projects related to the documents.
Static testing is done without executing any code.
It's reviewing of the particular documents.
Okay, so quickly I'll go through this one. So because when you wanted to understand V model, we need to understand what is verification and validation. When you wanted to understand the verification and validation, you should understand what you meant by static and then dynamic testing. So this is what the link. Okay, so now that's where we are here at static testing and the dynamic testing. Let's quickly see it. And means, as I told you, I don't know whether I have given it. So you can refer this particular link for having this particular testing information. You will have all type of testings over here. Did I share this particular link for you?
No, sir.
We have, sir.
No.
Okay. So this you can take care. So now, usually these are all the things which we will be talking about it. I think we have been just diverted at that point of time. So these all things has been missed. So usually you can have the complete type of testings over here. You can see all the models and type of testing: white box testing, black box testing, gray box. All these are methodologies, and what are the different type of techniques. White box testing techniques we will not discuss, because these are, you should know the names at least. His statement coverage, branch coverage, decision coverage, control flow, data flow. But usually who will do the white box testing?
Developers will do the white box.
Developers will be doing this one. So now at least black box testing, we will be going through this. And yeah, we have been covered all the test case development and non-functional testing we need to cover, and functional testings we have been discussed. So we are going to discuss about the test plan, test estimations, test techniques. These all things are there, so that we'll be discussing. So if you see here, the RTM will be discussing it, and test plan will be discussing it, test case reviews discussing it, test case testing techniques will be discussing it. So these all things we are going to discuss. That's in the future we are going to do it. And non-functional also we have been kept as a pending item, which it is not done. So test case development we have been covered as part of this one. So, and these are the different type of testing. So out this particular different type of testing, I think we have been covered only few, and few things we need to cover it up. However, keep this particular site as a reference, and then try to go through this one so that it will be better and easy for you to get understand. Okay, coming back, I don't want to deviate from the topic. Now coming back, what you meant by static testing and what you meant by dynamic testing. See, now we need to understand the static and dynamic, then we can understand where this particular verification and validation will comes into the picture. Now let's see the differences between the static and then dynamic testing. So I'll go a little bit faster here. If you didn't understand, you can stop me for sure. In static testing, we will check the code or the application without executing the codes. What do you mean by this?
Reviewing of the documents.
See, now what it will happen
Code
is,
review.
for example, now I have written the code. For an example, consider that this is an application. So I just wanted to show you some code and explain so that it would be easier for you to understand. So now I'm not going to execute that particular code, but I will verify whether the code is properly there or not. Now this is called as a code review. Now there are certain code review checklists would be there. Okay, whether they are following the basic standards of this one. So for an example, how the basic standards would be defined is, the standards. If you see here, now this is what the coding standards which we will be following it. For an example, if it is Java, see now I shown you, right? If it is a Python, we have different. If it is C#, it is different. If it is Java, it would be different. Now, when it comes to this particular thing, you can see that, hey, what are the contents which we need to do it? Means what are the things which we wanted to do it? For an example, if I creating a method name, so don't worry what is a method name and then variable names and all, anyways that will comes as part of your Java. So now there would be a certain standards when you're writing your piece of code, so then that particular code should have the basic standards. Now example, I'll show some things for you here. See now you'll be seeing it, right? So these are things are called as frameworks, and under the frameworks we'll be having this all, and all these things you'll be doing it very soon. Okay, so now if you see here, we are following certain standards in writing this one. Hey, it was starting with a small letter, it was starting with a small letter, here it is starting with a capital letter. Why it is started with a capital letter? And we do have you can see it. So here, if you see here, these are all methods we have been used. So these are called the methods. Now, when it is a method, it was started with a small letter. When it is a class, it was started with a capital letter. Now, am I executing anything? I'm just going through this and then I'm just verifying it. And whether we have been defining with a particular data type, what is this data type? And then we are seeing it, right? So don't worry, all these things, very soon you people will be writing it. So that's what we'll make sure. But here, what you need to understand is, without executing something, I can easily validate some. I can, sorry, not validate, I can verify some things. Now, these are the things which I'm verifying. So now, whether according to this particular standards, so I means whether these particular people has written the code or not. So these all informations I can check out, right? So that is how this standard should be there. And according to this particular standards, I'll be reviewing that particular code. So this is what the static testing means. But dynamic testing is nothing but we will execute that code and then we will see whether it is working properly or not. So now just we will go here and then start executing it and then we will see it. So now for an example, if I go here and I'll right click here and then I think it will throw me error, but still, yeah, this is where I started executing it. See, now it started executing and then it was working fine. We are seeing it, right? So it started doing the execution. It going the execution. It started the execution. So this is how, means I'm executing and then testing something. So then this is called dynamic testing. Without executing and then just verifying that particular content, then this is called static testing. So that is a basic difference between a static testing and this one. Now they have been given it very clearly. Examples, what you're trying to do. Hey, I wanted to do a code review. I wanted to do a code walkthrough. So these all things are called as static testing. But whereas in the dynamic testing, all your functional testing, non-functional testing, all the usability, integration, system level UAT, all these particular categories of testings will falls into the dynamic testing. Okay, so now this is called verification process. This is called validation process. Okay, and now what this would be like a making sure the things will not go wrong. So now these are the things when the things goes with identifying the things when it go wrong. So there is a slight difference between this one. So this will prevention, this will identify and cure. So now always you remember there would be one proverb, right? Prevention is better than cure. So now we are forecasting and preventing these particular bugs, but here we are identifying and then curing that or fixing that particular bugs in the dynamic testing. That is the difference between this dynamic and thing. Prevention and doing it. Example. I'm going, means I need to go for Goa. I'm planning my trip for Goa. Where I'm trying to go, I'll check my stepney, whether I do have an extra spare tire for me or not. So now this is what prediction or prevention. If I have any particular problem, I can make sure, hey, these are the things I need to check. Whether I have all the air in my tires, whether I have my fuel full tank, and whether my car engine is very good condition, and all my ACs and everything is working fine or not. Everything I'll check it and then I'll go. Okay, this is what means I'm making sure that nothing to be means any issues should come. Suddenly your car tire got punctured and then immediately you will change that one. So means you identify that first, you come across the defect or bug and you will try to identify the bug and you will try to fix that particular bug. Means comes when I'm driving it, so suddenly it rolled me, means it was giving me the jerks in the when I'm trying to drive the car. At that point of time, I identified that and I tried to change that particular, means identify the wheel and which wheel have the puncture, identified it, and I changed that particular wheel with the stepney. And once again, I'll fix my tire in nearby puncture shop. So this is what the fixing. So now this is where I'm giving some random examples, guys, to remember that what would be the static testing and the dynamic testing. So prevention would be the static testing major objective. And I always says you, what is an objective of any particular testing? Now, static testing objective is to prevent something, whereas the dynamic testing means basic things would be identify the things and fix that. So that is the basic differences between the static and this one. And this is the static testing is more cost effective process and less cost effective. Why? Consider that now I'm in my trip. I didn't have my stepney. My tire got punctured, or it's a flat tire. What I need to do? And it's in a forest. What I need to do? I need to stop my vehicle. I need to remove my tire, and I need to see where I am. If the Google Maps working, I need to go which is the nearest place. I need to just go there. I need to make it a puncture and then come back to the same location, and I need to fit that particular tire. How much time it taken, how much cost it taken. But if I have been previously prepared for it, if my tire got punctured, I have my stepney, I can put it so that I can go to the nearby place and then I can fill my tire or make it proper. How it would be. So always use, remember, identifying the bug as quickly as possible as a shift left process. See, now this is called shift left process. Now the complete industry was working on this particular shift left process. The shift left process is this. So now shift left means what is the current state before that one itself. If you identify the bug, the cost of the defect is less. It will not cascade it to the next one. So the same thing. So in our testing pyramids, the layers of pyramids, unit testing, unit layer, API layer, UI layer, and ETL, performance, security. If I identify the bug and fix here in the unit level itself, it saves me the time. Else it go to the UI layer and here, API layer, and the API layer I have the bug. If I don't fix in the API layer, then it will come to the UI layer, because this is called defect cascading. Cascading means moving from one place to another place. This is called defect cascading, right? So it was moving from one place to another place to the pyramid. So we should arrest this particular defects wherever it required and however it is required. Okay, so that the cost of the defect would be reduced. Now, before executing itself, if I have been trying to fix and identify that particular defect and fix that, so then that would be much more cost effective. But this is less cost effective. Then definitely the defect will be fixed, but it would be little more costlier. Okay, and these things are, you should know what is compilation and then executables. And these things I'll discuss when we're talking about the code. Okay, so you can take these particular 4 pointers, the basic difference between the static testing and the dynamic testing. Now coming back to here, it was the same pointers here we are going to do it. What is verification process and validation process? Okay, so now what do you meant by the basic verification and validation? So now whatever the pointers we have been discussed in the static testing, it would be similar. Means almost all it will be applicable for this one. But remember that static testing is verification test. No. Verification is a process which it would be used in the static testing. Validation is a process. It's a process. Always you remember, verification and validation is a process in testing. Okay, so don't misuse the terminologies. It is very, we have to be cautious. Verification and validation is a process that uses into the testing. Now, if you see here, now it was very clearly saying that verification process is checking the documents, design. Now you understand, right? Now, when we are designing, see, analysis and designing, before implementing this particular code, hey, whether verifying this particular design document is proper or not. So these all verifications. These are the verification processes. So now the execution processes would be comes into the validation. Okay, so this is where the basic differences means this verification process includes the documents, design, code, program, everything. But here it will execute that and validate whether it is working fine or not. So verifying is different process, validating is a different process. Validating it will comes when you do execution. Verifying is the process which before we start. So that is where it comes in the verification process. So when you're writing your test cases, also you have to be very cautious whether you need to use verify or validate. Which is the appropriate word when you wanted to use it in the test cases?
Validation.
Verify, sir.
Validating, sir.
Validation. Validate.
Nice. It is very simple. It is
It's
validating.
Validating. We are testing.
See, now when you are valid means when you are executing your test case, while you executing it, we are doing it. While doing the execution, what we need to use? Validate or verify?
Validate.
Validation.
Validate if it is working.
Validation.
Yes.
But many of the people will use verify. Yeah. So now when you write a test case itself, I can understand whether you have an experience or not.
So
Whether you know the
in
concepts or
smoke
not.
testing kind, we are actually verifying, or there also we are validating.
See, the basic problem is, see, this is completely a subjective information.
Yes,
So
kind of
see now how you are doing it. See, that is where if you understand the concept detailed, you should able to pick, hey, whether I need to use verify or validate. And it
Yes.
always differs and depends upon the type of testing which will be using it. And to me, what I feel is, say, some people there will be a strong argument also. But still, see, to me, by the definition of the IS2QB or by the definition of the IEEE, what it means for me was when you are executing something, you should do the validate. When you are pre-checking before the execution, if you are doing it, you should use verify.
Verification.
Even whatever the things I am trying to do, all my categories of testings and all the things I'll do with the validate, not with the verify. See, verify, it involves only in the code reviews. Hey, did you verify your code reviews? Did you verify your walkthroughs? Did you doing any other things? So these all things are static checkings or the verifications. And these all things would be your validations. And always the verification will help us to identify the bugs as quickly as possible early. And validation, once after the execution, then only we'll be getting it. So this is more sense to me to use it in all my test cases and all the types of testing. And if at all I'm doing the verifying the code, verifying the test case design, verifying the development design, and that you keep verifying. And always you remember, verification comes after, because after the execution only we'll be doing verification. Validation comes, it comes before that. See, they've given it one, vice versa. You can take anything. So now this is first and then this is second. That's where it is called as a shift left process.
So if there is any bugs, we can find out in verification only.
Some bugs we can't identify it until unless you execute it, right?
Yes.
See, now you can see, now we can verify that, hey, whether some documents are there, whether these things are there, you are verifying it. See, you are verifying when I'm going to on a trip, I verify my engine is working fine, and I will verify my flat tires are, my stepney is there, and air is there, fuel is there. But when you are going, suddenly the engine, there will be a fan, right? Engine the fan was broken because some rabbit entered or some fly, because of some bird hit your car. So because of that one, it was broken. During execution, we may not predict something. So now those things, when we got it, we need to fix it. We need to go further. You are making the pre-checks. So we are making a safety. Hey, nothing was there. So all my code is good. Rather than identifying this one later during the execution, we are making a pre-checks before itself. That is what verification. That's how you need. That's where I told you, right? Prevention. The prevention is what the part of the verification process. And validation process is identifying and fixing this. This is called validation. That's a simple definitions.
Curing it in that sense.
See, now if you go for different websites, they will give the different things. But you need to understand the concept of this car example. See, I read this before 15 years. I remember this one with a car example. Till now, I'm saying the same example. See, always you need to remember one live examples. So that's where you might think that why I'm giving the stories, but I remember that particular stories only. So that when we have, see now, very simple, if someone asks me the verification validation, many people will get confused. There is no confusion for me because I remember that, hey, keeping my stepney before going to travel is what my verification. And my tire got flat, then I'll identify which tire got flat and then I need to change this. Then this is my validation. So that's it. So that's how I remember. So that's where I'm just trying to give you an examples with it. So rather than remembering these definitions, you remember that examples you can remember. Hey, code walkthrough, design walkthrough, understanding these particular designs. These all things are called as a verification process and the validation process. Okay. Now, if you understand the verification and validation process, understanding the V model will be much more easier. See, guys, it is not really required to tell me about all this verification validation. Directly, I can jump here and then say it. But the problem is you will not really understand the science of V model. That's the reason I given you what do you meant by the verification process and validation process. If I tell you the verification validation process without static testing and dynamic testing, you will not understand. So that's the chain. That's how we need to explain so that you'll understand the end-to-end process. See how it is very easy. Hey, this is what the requirement gathering, and this is how the analysis, this is how the designing phase. Okay, this is how the designing phasing, the designing, and this is what the coding, and this is what the testing, and this is what the integration testing and the UAT. These are the different levels. V model is done. If I told you this, you will not understand the complete concept around this. What is the advantages and disadvantages? You should be able to derive this rather than me saying it. So, however, I'm sorry, it's already 11:06. I need to jump for other meeting. Fine. So now this will be continued tomorrow. Now from the V model. So just go through this one and then come back. And tomorrow, what is your